Paper.
Paper is a thin material produced by pressing together moist fibers, typically cellulose pulp derived from wood, rags or grasses, and drying them into flexible sheets. Paper is a versatile material with many uses. Whilst the most common is for writing and printing upon, it is also widely used as a packaging material, in many cleaning products, in a number of industrial and construction processes, and even as a food ingredient, particularly in Asian cultures. Paper, and the pulp paper-making process, was said to be developed in China during the early 2nd century AD, possibly as early as the year 105 AD, by the Han court eunuch Kai Lun, although the earliest archaeological fragments of paper derive from the 2nd century BC in China. The modern pulp and paper industry is global, with China leading production and the United States behind it.
History.
The oldest known archaeological fragments of the immediate precursor to modern paper date to 2nd century BC in China. The pulp paper-making process is ascribed to Kai Lun, a 2nd century AD Han court eunuch. With paper an effective substitute for silk in many applications, China could export silk in greater quantity, contributing to a golden age. Paper spread from China through the Middle East to medieval Europe in the 13th century, where the first water-powered paper mills were built. In the 19th century, industrial manufacture greatly lowered its cost, enabling mass exchange of information and contributing to significant cultural shifts. In 1844, Canadian inventor Charles Feenity and German F. G. Keller independently developed processes for pulping wood fibers.
Etymology.
The word paper is etymologically derived from Latin papyrus, which comes from the Greek papyros, the word for the cyperus papyrus plant. Papyrus is a thick, paper-like material produced from the pith of the cyperus papyrus plant which was used in ancient Egypt and other Mediterranean cultures for writing before the introduction of paper into the Middle East and Europe. Although paper is etymologically derived from papyrus, the two are produced very differently and the development of modern paper is separate from the development of papyrus. Papyrus is a lamination of natural plants, while paper is manufactured from fibers whose properties have been changed by maceration or disintegration.
Papermaking. Chemical pulping.
To make pulp from wood, a chemical pulping process separates lignin from cellulose fibers. This is accomplished by dissolving lignin in a cooking liquor, so that it may be washed from the cellulose fibers. This preserves the length of the cellulose fibers. Paper made from chemical pulps are also known as wood-free papers, not to be confused with tree-free paper. This is because they do not contain lignin, which deteriorates over time. The pulp can also be bleached to produce white paper, but this consumes 5% of the fibers. Chemical pulping processes are not used to make paper made from cotton, which is already 90% cellulose. There are three main chemical pulping processes. The sulfate process dates back to the 1840s, and it was the dominant process before the Second World War. The Kraft process, invented in the 1870s and first used in the 1890s, is now the most commonly practiced strategy. One advantage is a chemical reaction with lignin produces heat, which can be used to run a generator. Most pulping operations using the Kraft process are net contributors to the electricity grid or use the electricity to run an adjacent paper mill. Another advantage is the process recovers and reuses all inorganic chemical reagents. Soda pulping is a specialty process used to pulp straws, bagasse, and hardwoods with high silicate content.
Mechanical pulping.
There are two major mechanical pulps, thermomechanical pulp, TMP, and groundwood pulp, GW. In the TMP process, wood is chipped and then fed into large steam-heated refiners where the chips are squeezed and made into fibers between two steel discs. In the groundwood process, debarked logs are fed into grinders where they are pressed against rotating stones and made into fibers. Mechanical pulping does not remove the lignin, so the yield is very high, greater than 95%, but also causes paper made from this pulp to yellow and become brittle over time. Mechanical pulps have rather short fiber lengths and produce weak paper. Although large amounts of electrical energy are required to produce mechanical pulp, it costs less than chemical pulp.
Dyeing pulp.
Paper recycling processes can use either chemical or mechanical pulp. By mixing with water and applying mechanical action, the hydrogen bonds in the paper can be broken and fibers separated again. Most recycled paper contains a proportion of virgin fiber in the interests of quality. Generally, dyed pulp is of the same quality or lower than the collected paper it was made from. There are three main classifications of recycled fiber. Millbroke or internal mill waste. This incorporates any substandard or grade change paper made within the paper mill, which then goes back into the manufacturing system to be repulped back into paper. Such out-of-specification paper is not sold and is therefore often not classified as genuine reclaimed recycled fiber. However, most paper mills have been recycling their own waste fiber for many years, long before recycling became popular. Pre-consumer waste. This is offcuts and processing waste, such as guillotine trims and envelope blank waste. This waste is generated outside the paper mill and could potentially go to landfill, and is a genuine recycled fiber source. Also includes de-inked pre-consumer, recycled material that has been printed but did not reach its intended end use, such as waste from printers and unsold publications. Post-consumer waste. This is fiber from paper which has been used for its intended end use and would include office waste, magazine papers and newsprint. As the vast majority of this paper has been printed, either digitally or by more conventional means such as lithography or rotogravure, it will either be recycled as printed paper or go through a inking process first. Recycled papers can be made from 100% recycled materials or blended with virgin pulp. They are, generally, not as strong nor as bright as papers made from virgin pulp.
Additives.
Besides the fibers, pulps may contain fillers such as chalk or china clay, which improve the characteristics of the paper for printing or writing. Additives for sizing purposes may be mixed into the pulp and or applied to the paper web later in the manufacturing process. The purpose of sizing is to establish the correct level of surface absorbency to suit the ink or paint.
Producing paper.
The pulp is fed to a paper machine where it is formed as a paper web and the water is removed from it by pressing and drying. Pressing the sheet removes the water by force. Once the water is forced from the sheet, felt, not to be confused with the traditional felt, is used to collect the water. When making paper by hand, a blotter sheet is used. Drying involves using air and/or heat to remove water from the paper sheet. In the earliest days of papermaking, this was done by hanging the paper sheets like laundry. In more modern times, various forms of heated drying mechanisms are used. On the paper machine, the most common is the steam-heated can dryer. These dryers can heat to temperatures above 200 DEGF, 93 DEGC, and are used in long sequences of more than 40 cans. The heat produced by these can easily dry the paper to less than 6% moisture.
Finishing.
The paper may then undergo sizing to alter its physical properties for use in various applications. Paper at this point is uncoated. Coated paper has a thin layer of material such as calcium carbonate or china clay applied to one or both sides in order to create a surface more suitable for high-resolution halftone screens. Uncoated papers are rarely suitable for screens above 150 lpi. Coated or uncoated papers may have their surfaces polished by calendaring. Coated papers are divided into matte, semi-matte or silk, and gloss. Gloss papers give the highest optical density in the printed image. The paper is then fed onto reels if it is to be used on web printing presses, or cut into sheets for other printing processes or other purposes. The fibers in the paper basically run in the machine direction. Sheets are usually cut long grain, that is with the grain parallel to the longer dimension of the sheet. All paper produced by paper machines as the Fourdrinier machine are wove paper, that is the wire mesh that transports the web leaves a pattern that has the same density along the paper grain and across the grain. Textured finishes, Watermarks and wire patterns imitating handmade laid paper can be created by the use of appropriate rollers in the later stages of the machine. Wove paper does not exhibit laid lines, which are small regular lines left behind on paper when it was handmade in a mold made from rows of metal wires or bamboo. Laid lines are very close together. They run perpendicular to the chain lines, which are further apart. Handmade paper similarly exhibits decal edges, or rough and feathery borders.
Applications.
Paper can be produced with a wide variety of properties, depending on its intended use. For representing value, paper money, banknote, check, security, see security paper, voucher and ticket. For storing information, book, notebook, magazine, newspaper, art, zine, letter. For personal use, diary, note to remind oneself, etc. For temporary personal use, scratch paper. For communication, between individuals and/or groups of people. For packaging, corrugated box, paper bag, envelope, packing and wrapping paper, carta empiritica and wallpaper. For cleaning, toilet paper, handkerchiefs, paper towels, facial tissue and cat litter. For construction, papier-mâché, origami, paper planes, quilling, paper honeycomb, used as a core material in composite materials, paper engineering, construction paper and paper clothing. For other uses, emery paper, sandpaper, blotting paper, litmus paper, universal indicator paper, paper chromatography, electrical insulation paper, see also dielectric and permittivity, and filter paper.
Types, thickness and weight.
The thickness of paper is often measured by caliper, which is typically given in thousandths of an inch in the United States and in thousandths of a millimeter in the rest of the world. Paper may be between 0.07 mm, 0.0028 in, and 0.18 mm, 0.0071 in, thick. Paper is often characterized by weight. In the United States, the weight assigned to a paper is the weight of a ream, 500 sheets, of varying basic sizes, before the paper is cut into the size it is sold to end customers. For example, a ream of 20 pounds, 8.5 in x 11 in, 216 mm x 279 mm, paper weighs 5 pounds, because it has been cut from a larger sheet into 4 pieces. In the United States, printing paper is generally 20 pounds, 24 pounds, or 32 pounds at most. Cover stock is generally 68 pounds, and 110 pounds or more is considered card stock. In Europe, and other regions using the ISO 216 paper sizing system, the weight is expressed in grams per square meter, GM2 or usually just G, of the paper. Printing paper is generally between 60 G and 120 G. Anything heavier than 160 G is considered card. The weight of a ream therefore depends on the dimensions of the paper and its thickness. Most commercial paper sold in North America is cut to standard paper sizes based on customary units and is defined by the length and width of a sheet of paper. The ISO 216 system used in most other countries is based on the surface area of a sheet of paper, not on a sheet's width and length. It was first adopted in Germany in 1922 and generally spread as nations adopted the metric system. The largest standard size paper is A0, measuring 1 square meter, approximately 1189 x 841 mm. Two sheets of A1, placed upright side by side, fit exactly into one sheet of A0 laid on its side. Similarly, two sheets of A2 fit into one sheet of A1 and so forth. Common sizes used in the office and the home are A4 and A3. A3 is the size of two A4 sheets. The density of paper ranges from 250 kg per meter 3, 16 pounds per cubic foot, for tissue paper to 1,500 kg per meter 3, 94 pounds per cubic foot, for some specialty paper. Printing paper is about 800 kg per meter 3, 50 pounds per cubic foot. Paper may be classified into 7 categories. Printing papers of wide variety. Wrapping papers for the protection of goods and merchandise. This includes wax and craft papers, writing paper suitable for stationery requirements. This includes ledger, bank, and bond paper, blotting papers containing little or no size, drawing papers usually with rough surfaces used by artists and designers, including cartridge paper, handmade papers including most decorative papers, Angra papers, Japanese paper and tissues, all characterized by lack of grain direction, specialty papers including cigarette paper, toilet tissue, and other industrial papers. Some paper types include
Paper stability.
Much of the early paper made from wood pulp contains significant amounts of alum, a variety of aluminium sulfate salts that is significantly acidic. Alum was added to paper to assist in sizing, making it somewhat water-resistant so that inks did not run, or spread uncontrollably. Early papermakers did not realize that the alum they added liberally to cure almost every problem encountered in making their product would eventually be detrimental. The cellulose fibers that make up paper are hydrolyzed by acid, and the presence of alum would eventually degrade the fibers until the paper disintegrated in a process that has come to be known as slow fire. Documents written on rag paper were significantly more stable. The use of non-acidic additives to make paper is becoming more prevalent, and the stability of these papers is less of an issue. Paper made from mechanical pulp contains significant amounts of lignin, a major component in wood. In the presence of light and oxygen, lignin reacts to give yellow materials, which is why newsprint and other mechanical paper yellows with age. Paper made from bleached kraft or sulfate pulps does not contain significant amounts of lignin and is therefore better suited for books, documents and other applications where whiteness of the paper is essential. Paper made from wood pulp is not necessarily less durable than a rag paper. The aging behavior of a paper is determined by its manufacture, not the original source of the fibers. Furthermore, tests sponsored by the Library of Congress prove that all paper is at risk of acid decay, because cellulose itself produces formic, acetic, lactic and oxalic acids. Mechanical pulping yields almost a ton of pulp per ton of dry wood used, which is why mechanical pulps are sometimes referred to as high-yield pulps. With almost twice the yield as chemical pulping, mechanical pulps is often cheaper. Mass-market paperback books and newspapers tend to use mechanical papers. Book publishers tend to use acid-free paper, made from fully bleached chemical pulps for hardback and trade paperback books.
Environmental impact of paper.
The production and use of paper has a number of adverse effects on the environment. Worldwide consumption of paper has risen by 400% in the past 40 years, leading to increase in deforestation, with 35% of harvested trees being used for paper manufacture. Logging of old-growth forests accounts for less than 10% of wood pulp, but is one of the most controversial issues. Paper waste accounts for up to 40% of total waste produced in the United States each year, which adds up to 71.6 million tons of paper waste per year in the United States alone. Conventional bleaching of wood pulp using elemental chlorine produces and releases into the environment large amounts of chlorinated organic compounds, including chlorinated dioxins. Dioxins are recognized as a persistent environmental pollutant, regulated internationally by the Stockholm Convention on Persistent Organic Pollutants. Dioxins are highly toxic, and health effects on humans include reproductive, developmental, immune and hormonal problems. They are known to be carcinogenic. Over 90% of human exposure is through food, primarily meat, dairy, fish and shellfish, as dioxins accumulate in the food chain in the fatty tissue of animals.
Future of paper.
Some manufacturers have started using a new, significantly more environmentally friendly alternative to expanded plastic packaging made out of paper, known commercially as paper foam. The packaging has very similar mechanical properties to some expanded plastic packaging, but is biodegradable and can also be recycled with ordinary paper. With increasing environmental concerns about synthetic coatings, such as PFOA, and the higher prices of hydrocarbon-based petrochemicals, there is a focus on zein, corn protein, as a coating for paper and high-grease applications such as popcorn bags. Also, synthetics such as derived and tessellin have been introduced as printing media as a more durable material than paper.